Welcome. Hi, everybody. Can you hear me okay? If so, just send a quick message on the chat box. Okay. Welcome to today's webinar, right? My name is Rodrigo Bárcena. I'm talking to you guys, presenting from the European office of McNeil, right? We're in Barcelona, as you probably know, right? And today's webinar will be presented, or will be carried actually, by our colleagues or friends, collaborators, trainers, resellers from Rhino Center in the Netherlands, okay? Well, that's us, in case you were wondering where I'm talking from, right? And as I was telling you, today's presenters will be Gerard Petersen and Bas Goris from Rhino Center in the Netherlands, okay? Hi, guys. I'll be your host today, and in a couple of minutes, I will just be passing the control to these two, I don't know how you call you guys, just trainers, Rhino experts, pandits, gurus. Anyway, they will be presenting you the material that they have been working on in the last months, actually years, because if I'm not wrong, all these rapid hull modeling techniques or methodologies started in 2012. Okay, and lately they have gathered all this knowledge in a series of online courses that they would like to present you, give you a snippet, an overall look of what you will learn in these trainings, and hopefully do a couple of quick exercises showing you some interesting techniques for all of you marine designers and naval architects. Okay, so I'll just step aside and pass control to Gerard. I will unmute you now. And yeah, hi Gerard.
Hi.
I'll just pass control, and well, I will stay in the background answering questions along with our colleague Mary from the US. Sorry, Mary, I forgot to add your photo here in the in the roster, and but yeah, we'll be also online. Okay, so Gerard, you are now the presenter, and well, good luck.
All
I
right.
will also close my webcam.
All right. Welcome, everybody. When I see that actually right now 154 people are attending this webinar, I'm very happy that you all take the time to look at what we like to show you this afternoon. For us, it's the afternoon. This morning, we gave the first session of this webinar, and that is the similar session as we do right now. Again, I'd also like to thank McNeil and Associates for hosting this webinar for us, because for me it's the first time, actually the second time right now, to give a webinar. And it's a bit of a weird feeling that actually more than 150 people are in front of me right now, and maybe you are sitting at your office or at your kitchen table. It doesn't matter. We are all in the same area right now. First, I like to explain a little bit about the program of this session. So first, I will explain a little bit about what you can do with Rhino when it comes to hull modeling and fairing or reverse engineering a vessel hull. So what is Rhino capable of, and what is our history with Rhino when it comes to using it in the maritime industry. Then there is a little explanation about the plugins that you can use in Rhino, and after that my colleague and friend Bas Goris, who is also a naval architect, will explain a couple of topics. And the first one is, I guess, the most fundamental one. It's about rapid hull modeling methodology in Rhino that he developed together with Phil Shapiro in 2002, already right then. Now you see my screen, actually, so I'm sorry for that. So you see an overview of the contents of the webinar, and you see at the right-hand side an image of an open motor boat that I developed in 2001. Regarding the content of this webinar, Hull Design and Fairing Level 1 is a training module that contains the basics of the rapid hull modeling methodology. Bas will show you the basics of how it works, and also he will show, for example, the making of a lines plan drawing with that method. Also, he will show you a file that you receive in this training module that contains a couple of example ship hulls, boat hulls, and yacht hulls. After that, I will continue to show you how you can use 2D information from, for example, an AutoCAD drawing or a PDF, an image, a raster a PDF, or a vector PDF, and how you can use that in Rhino to create 3D geometry. Then it is time to show you some more advanced topics when it comes to, for example, reverse engineering with Rhino. Whether you have an existing 2D lines plan, a 3D lines plan, or a laser scan point cloud, for example. How you can use that and recreate a 3D and fair hull shape. The next topic will be about developable boat hulls. That is a part of the maritime industry in which people create often a bit smaller size workboats, tugboats, and how you can do that with Rhino. So also in the training module Hull Design and Fairing Level 2, you will learn more about developability and how to unroll strakes of your ship hull. The next topic is that I will show you a little bit more about the training modules that we developed and that are available on the Rhino Center website, how they work and what you can find over there. The last part of this session is the questions. So I would like to invite you all to write down sessions in the chat box. We will read them during the webinar, and also during the answering of the questions we can read more questions. And this morning session, well, we expanded it a little bit because the questions were so nice and we were so happy to answer them. When we are not able to answer your specific question, we will probably write it down on the specific webinar page on the Rhino Center website, or we will send you an email afterwards that shows you, that gives you the answer actually. Now I will move back to the first part of this webinar, and it's a little background information. I found Rhino back in 2000 already, when I was looking for a tool to be able to design integrally the motorboat that you see at the right-hand side of the overview page. The Trimaran K-Now, I needed software to not only develop a ship hull, which was quite unique at that time, but also I wanted to use Rhino for modeling the interior, the convertible top, and also even the structure, the frames, steering, etc. I found Rhino and I fell instantly in love with it because it enabled me to do all these things in Rhino. Of course, in the marine industry today, most companies use other engineering software, and please continue to do so. However, I find Rhino a perfect tool for initial design, detailed design, and maybe collaborate with engineering software too. I see that most of our maritime clients use Rhino together with other software, and that works fine. McNeil and Associates asked me to become a Rhino reseller, and in 2003 I started Rhino Center to sell the software, and later in 2007 also to offer training, because more and more clients asked me, hey Gerard, can you teach us how to do nice work in Rhino? Also, we provide services at Rhino Center, so sometimes we model a hull, we do visualization, and also My colleagues are able to program Rhino. So sometimes we do scripting or plugin development. As I gave more and more training, I decided in 2012 to develop actually a hull design and fairing training, because I saw that there was a need for practical tools how to model a decent ship hull in Rhino. What I see a lot in the maritime industry is that people model ship hulls as a patchwork of surfaces. And when it is successful once, it is a very difficult job to edit a patchwork of surfaces when the client says, I want it longer or more volume in the bow area. So the rapid hull modeling methodology enables me and other people to create a very nice hull in little time that is easy editable. So in 2012, I developed this hull design and fairing training for professionals in the maritime industry. And lucky for me, the method is applicable to both modeling, fairing, and also reverse engineering. So a lot of jobs and tasks you can do with the technique. Also, it's applicable to many ship types. So not only ships, but also yachts and workboats. Single hulls, multi-hulls, nearly all ship types are possible with this technique. So it's very good for most people in the business, actually. It turned out to be a 4-day classroom training. And I offered that several times to leading companies in the Netherlands in the maritime industry, and even in France. And I once went to Japan to offer training for hull modeling over there. But I also found out that a lot of companies don't have so many people who need to do this job. So one-man businesses or a small shipyard where only 1 or 2 people need to do this fairing job, then it's simply too expensive to visit the Netherlands or to ask me to visit you. And therefore, I decided in 2017 to convert this classroom training into an online training. It's a self-taught, autodidact training. And in that training, you can learn this all yourself, and you can get some online support only if you want it. This training is based on Rhino only. That was a very specific choice that I made right then. However, for naval architects, the Orca 3D plugin is an extremely valuable add-on for hydrostatic analysis, impact stability analysis, weight calculation, and today also CFD calculation is possible with Orca. And that enables me as a designer to find solutions that are maybe very clever, but I can even compare 3 ship hulls with Orca 3D CFD and find out which one shows the best results. At a later stage, I can always consult a specialist in the industry to validate my specific hull. Another very valuable plugin that needs much more attention is scan and solve for finite element method calculations. Again, I can, as a designer, do some strength analysis on, for example, a clever crane foundation or a door in my ship hull, a ramp on a ferry, etc. And when I have my concept design ready, I can do a calculation with scan and solve and see that maybe my idea is quite good, but needs some more attention in a specific area. The Grasshopper plugin is now integrated in Rhino 6. Grasshopper is a visual scripting tool that I and my colleague Bas use, for example, for a parametric hull script. So when you learn to model a ship hull by hand, the next step might be that you put it into a Grasshopper script, and then you can easily edit the shape, the volume, the center of buoyancy, and see the result. Another script might be a tank arrangement script that I developed for fun years ago, and well, that can be valuable for large vessels, merchant vessels. I also use bongo animations in Rhino, and then I can, for example, show the opening of a door in a hull. At last, the rendering plugins like Flamingo, which is a McNeil product, or V-Ray, that is to make your design, to turn it into a nice image and to show your client how beautiful your design is. But training and this webinar is based on only Rhino. And this training is also, you can do this training also still in Rhino 4, 5, and now in Rhino 6. So that brings me to the next part of this webinar, the Hull Design and Fairing Level 1 training module, in which Bas will show you about the rapid hull modeling methodology. So I would like to invite Bas to present the next part.
Thank you, Gerard. That's, I will get my screen for you all. I'm going now to look to Rhino itself, make presenter. Okay, well, hello, my name is Bas Goris, and I will show you some practical stuff. Here you see some curves. I will make this small, yeah. And these curves are based on control points, and here you can see a mainframe. And in the training, we will teach you how to make a mainframe out of one curve. So it's not one line and then a fillet and then another line. No, it's one curve. And we do that by changing the weight. If I type in weight in the command line, you can see that it has a certain figure and that it is pi divided by 9. So, and we will teach you more about that. But we start with a mainframe. From the mainframe, we create all the other curves. And then we're going to teach you how to use the loft. And I will show you now a short version. I will, in the bottom, I will activate record history, and I type in the command loft in the command line, and then I select all the curves that I have here, and I press enter, and then I get this menu, and there are different options: normal, tight, straight sections. For example, normal, you already see that the ship, well, it's ugly. Same for straight sections. That is only very nice if you already have made the curves in that way that you can make straight sections. And the one that we want to use as naval architects to get a fair hull is the loose. So I always say do not simplify, and then okay. And then we have a hull which is nice and smooth. But how to check that? There are different ways, and that's something that we teach as well in the training. One of it is that we have created, and we learn you how to install it in the training, the glossy for fairing rendering. I will make this large, and the advantage of this is that you get a certain black light over the vessel, like the old naval architects did by painting the hull black and putting light over it, so they could see where some bumps were. And for example, if I now change one of the curves and I make a bump by just changing, you can see that also you see that the lightning change. So that helps. So that's one way. I will do undo. What I forgot to show is what is nice is about record history, what we activated here in the bottom. if I now change, for example, I want to change the length of the ship, I just can do it, and by changing the loft curves, and my ship is lengthened. So there are many ways to deform, and we will teach that more. Oh, and there another way to check your result is via lines plan. It's an old-fashioned but still very valuable method. And how to make a lines plan in Rhino is by the command contour. I will show you, and I will activate the layer that I made for waterlines, and then I type in the command contour. And then it's asked me to select for the objects. So I select half the hull. And then it asks me for the contour base point. And as I've drawn the ship with the baseline of the ship on the Z is 0, and the mirror is on F0. So I use for the base point, I use 0. I can type in 0, 0, 0, but 0 is enough in Rhino. And then it asks me for the direction perpendicular to the contour planes. Well, I want waterlines, and the direction perpendicular to that is the Z-axis. So I point upwards. And then it asks me for the distance between the contours. And my model is in millimeters, so if I type in 1, I will get millions of waterlines. That's not something I don't want. 1 meter is a nice distance, so thousands it is now showing here, so I accept that. And there are my waterlines. And I've prepared already the buttocks. Here you can see, for example, I can make these visible. So now you can see, you also see the loft lines, but you see the lines plan, and you can check that as well. And you see that I've lengthened, I've made the water lines of the lengthened part. So sorry for that, but I think you understand the idea behind it. Okay, let's check my list. What is next? Yeah, then what we will provide via the training is also different ship types. I will show.
1 second, Bas.
Yeah.
Do you also do the hydrostatics?
Oh yeah, the hydrostatics I forgot. Yeah. There is also a function for hydrostatics. It's just called hydrostatics in Rhino. Hydrostatics, there it is. And it's asked me here for a waterline elevation, and as my waterline elevation at the 0, Z is 0, is the baseline, the bottom line, I will not get anything. Symmetric, that's I have to type in for yes if I only use half the hull. And then I have longitudinal the direction of X, and that is there. And then I can select, and then you see I get waterplane area is 0, because it is the baseline now. I repeat with my right mouse button, I type in now a waterline elevation, and I have to choose it below the height of the open mirror, the stern, because the stern is still open. And so that is about 3 should be okay, 3000. I click on it, and you see then you get the hydrostatics. And if you want the hydrostatics of a draft that is where you have the mirror on the water, then you should make a closed stability hull, which I've made here. So then you have to make a stern and a deck and close it completely, and then you can use hydrostatics for all the drafts that you want. Okay, and then I will show you some of the vessels that are in the file. This file that you see here is also available in the training. And for example, here you see a ship with a knuckle in the bow. And here it is fair, and more to the aft, it is fair again, but there's one loft curve with a knuckle, and it is not a curve made of two lines. No, this control point is made a knuckle point. I'm going to show you in this, the front view as well. Okay, and now here another example, but more special about it is that you also can make propeller sterns. Another one. More simple barge. And then the yachts. A nice mega yacht. And then much smaller, so we'll zoom in. A nice sailing yacht. And for example, to show you the loft curves, 1, 2, 3, 4. So a sailing yacht is much simpler to make. There are only 4 loft curves, and the loft curves, this loft curve only has 4 control points. So that is the trick about the whole thing. Use as less as possible curves and as less as possible control points, and we will teach you how what the technique behind this to manipulate these control points on a smart way. And a sloop. You see, this is all possible with the same method, this rapid hull methodology, with the loose loft method within Rhino. A planing hull, and Gerard in the next presentation will show more. And a nice tugboat. Well, a pilot boat. And one, well, semi-planing boat. Okay, this is it. And I will hand over the presentation to Gerard. There it comes, Gerard.
All right. The next part of the presentation, I will move my webcam to the other screen, is to prepare to the input. Before we can go to reverse engineering with Rhino, for example, to create a fair hull based on an existing lines plan, there is this prepare to the input module. And in that training module, you learn how to convert 2D drawings, for example, DWG drawings, and prepare them in such a way that you can make use of them in a clever way. In the past, I simply opened an AutoCAD drawing in Rhino and started modeling 3D geometry in that. But often AutoCAD drawings are polluted with blocks, with many layers, hatches, etc. And then I quickly deleted a lot of information in that AutoCAD drawing. And then at a later time, I had no idea which version I actually used to create my 3D material. So what we see here is a 2D general arrangement plan that you are probably familiar to in your business. And then the next file, and that's not this one shows you how you can convert it, and then every deck is at the correct elevation. So I can simply turn off a couple of layers, and for example, the text of this drawing I can turn off, the profile part, the front view and the centerline section, and now I only have 2 decks that are at the proper elevation. And then when I turn on my pilot boat, you see that I can easily use these 2D information to create 3D geometry from it. And also on the deck below, here you find the footprint of this geometry. So this prepared 2D input is not only interesting for those who need to reverse engineer a ship hull based on a 2D drawing or a general arrangement plan, but it's also very valuable for anyone who needs 2D drawings to create 3D geometry, even architects or industrial designers. So the prepared 2D input module is then applicable. Where we use this module for is for the next step in the training series, and that is the reverse engineering of this specific hull of an anchor handling tug and supply vessel. So what we see here is the result from a 2D image, and I need to find it. I think I closed it, so I will open it again. And here, this is a PDF, and it's actually a raster PDF. So it's not a vector PDF, but it's just an image baked in a PDF. So this 2D image, you learn how to convert it into this 3D thing, and then we make use of it, and I will show you how that works. I turn off several layers, for example, B deck, A deck, starboard profile, and maybe the tank top. And now you see that I have only 2 decks visible, and I can turn off the end result. Then you see that I need, for example, this waterline, and the idea behind this technique is to trace the curve first. So I trace this curve, and then I decide to which accuracy I would like to reverse engineer my hull. In the layer manager, you see 2% of the maximum breadth is what I use mostly when I do reverse engineering. So the accuracy is at least within 2% of the maximum breadth of the hull. And that leads to so-called reference ribbons of plus 175 millimeters and minus 175 millimeters. And I create them for all these waterlines. This is a general arrangement plan, but you can also do this when you have a lines plan, an AutoCAD lines plan, for example, the ordinates, the stations, or the buttocks. So you can always create these reference ribs. When I have the reference ribs, then I can turn off the original input. So here you see the aft ship, and here the bow area. And then when I click on my hull, you notice, and if I click on the loft curves, that this hull was actually recreated by only a couple of loft curves. I see that I have some clutter that I will delete right now. And now if I select everything and deselect my hull shape, you see that these are the loft curves that I created in order to get to this hull surface. As Bas already mentioned, the challenge is to use as few loft curves as possible and to use as few control points per curve as possible. And that gives you hopefully enough control, but not too much, and that leads to easy, fair hulls. When I turn on the control points of the surface, you will notice that the control points of the surface are at the same position as the curve points, and that is only possible when each loft curve has the same amount of control points. So that's the case over here. And now I will show you why these reference ribs do their work. What I have actually done, I started with a complete new surface, and now the challenge is to get it within the tolerance of the reference ribs. And as you can see, in this bow area, I am everywhere within tolerance, plus or minus 175 millimeters. So that's the challenging part of it. How to get my new surface accurate enough and also fair enough. Let me see in my program. I think there will be questions later that I will answer. I'm happy to answer them later. And I would like to continue now with the next part of the webinar, and that is to open a file that shows you a workboat. So a lot of people in the maritime industry are focusing on multi-chine workboats, tugs, etc. One important aspect then is, hey, I want to fabricate this ship. Is it developable, yes or no? In that case, Rhino offers some tools that you will learn in this Hull Design and Fairing Level 2 training module. So I click on the surface and I go to Analyze, Surface, Curvature Analysis. And all of a sudden, the whole object turns mostly into green. Over here, we see curvature, style, Gaussian, and that is the analysis to examine the developability of the strakes. The range is very important and determines the sensitivity. And for now, I will take a look at this specific setting. This strake already shows totally green, but you might already understand that over here we have a warped surface due to this weird shape over here. So the challenge then is to edit the shape over here in such a way that this blue area turns into green. So I can click on this curve and I can manipulate the position of this specific control point by moving it afterwards. And now you see that over here, the green part is getting bigger. However, over here we introduce a bluish part. And then maybe I need to edit the shape of this control point in such a way that it becomes better. Wow, everything is green now. So then I can decide to test it. The proof of the pudding is the eating. I can explode my hull, select this specific strake, and I type unroll. And I press enter. And now here we have the unrolled result. And when I press function 2 key on my keyboard, over here it tells me the area difference is within tolerance. So this is highly accurate unrolling of this surface. Over here we see a part that is still blue, and that is something that you also learn more about in training, because this is a bottom strake containing only 3 edges, 1, 2, 3. There is a problem because any NURB surface always contains 4 edges. What we have done over here is this part is the 4th edge, and that's in line with the keel. And then the Gaussian analysis has a problem and will always tell that this is blue. But if I say unroll, here we find the end result. And when I press function 2 key, the area is 0.01% bigger. So that's very close. This is what I would like to show you in this session regarding developable boat hulls. And the next part of the webinar, I will show you more about the training modules. So I will open the Rhino Center website, and in the Rhino Center website you have this training area. I decided to offer the training modules separately as 3 modules, and you can also purchase the 3 in a bundle with a discount. As I expected that some people say, hey Gerard, I want to do your training, but I don't want to pay for support, I decided to offer over here online training support separately. So you can select 1 up to 4 hours when you want us to support you. From my experience, it's very important to receive a certain amount of support, because I found out in the classroom training that it is not so easy to integrate all the aspects of hull modeling and fairing into a daily practice, because it's simply a lot of stuff you have to think about. So online training support will help you to integrate the learned lessons during the training. After the training, you can purchase online feedback support, and then you can send us files of results that you made in your own practice. We take a look at it, give you feedback, and help you out. What's also maybe interesting is this online training demonstration video. Then you can find out how the training works and how also the exercise files work, because we have been thinking a lot about what is practical when people do the training. So how can we set up the Rhino files in such a way that people don't lose track during the training? So I will show a little bit in this video, not now. In the training products, if I click on a training product, again, I explain here that this training module is sold without support and you can purchase separately. But more to the bottom side, here is a very detailed description about the training content of this specific module. And at the very bottom, we have literally published one exercise, so you have an idea what you buy with this training module. So any exercise in the training series in these training modules contains a demonstration movie of the exercise. In this exercise 10 is the very big one, so we have 2 videos, and then any exercise is written step by step, written out step by step over here. So you can take a look at the video very relaxed, and then you can practice yourself over here. This is about the product description, and when you purchase a product, after purchasing a training module, it becomes visible over here, here, and here, depending on what you purchase. And then you are able to take a look, and I will close a couple of sessions I opened this morning. So for example, this training module, when you purchase it, it looks like this. Here, the table of content, and then, for example, the files that you will find when you download the training files. you can receive a certificate of completion if you send in some tasks that we describe over here. And then I scroll down rapidly to the first big exercise to model a hull from a 2D lines plan or a general arrangement drawing. And then here first the movie, and then the same exercise that was explained in the movie is written out, very detailed, step by step. So this should make it possible for anyone to follow this training. And let me see in my program. Yes, I already explained about the separate training support. When you decide to purchase a training and you don't purchase often on a web shop, for any registrant to this webinar, in the registration email you received a discount code. So when you decide to, for example, purchase this hull design and fairing level 2, you can add it to your cart, and then you can apply a coupon code here that you received in the email, fair 20%, and say apply coupon code, and that gives you the 150 euros discount on this specific training module. That brings me to the end of this presentation, and now I'm very curious what your questions are. So I hope that Bas already prepared an answer to one or more questions. So if Bas is willing to take over, I'm more than happy to hear his answers.
Yes. I have some questions. I'll take over.
Shall I make you
Sorry?
present?
No, I can do it myself.
Okay.
Oh, you already did. Yeah. Okay. Okay, close this, that. Okay, back to the Rhino screen of the loose loft. One of the questions is how to decide how many loft curves how many loft curves you need, or how to decide about the shape of the curves. And I will tell a bit of some of the rules that we teach you in the training. One thing you see here already is that you see a straight line here. Well, if I move one of the curves, it's not a straight line anymore. And one very important basic rule about curves, but also about surfaces, is that when there are 3 points in one line, in straight line, the curve will be going into straight. So 1, 2, 3, and from here on it is straight. 1, 2, 3, and then it is straight. So it's the same for the surface, because all the loft curves do have control points. And here we, for example, let's have a look to one more curves. So here the surface is curved. I will make, well, maybe more, let's put the stability hull on here. So here the surface is curved, and here we want the parallel midship. So this curve has points that are already on the breadth of the ship. It's the first point at that breadth, and then the second point is on that curve and that curve. So 1, 2, 3, and then it is completely straight. Here it is still, it looks straight, but mathematically it is not. So this is one important rule for control points we also use for loft curves. And yes, the shape of the midship is clear. I mean, you want a certain build radius, you want a certain breadth, and you want a certain depth. That's something you, as designer, you want, and you have, or you copied from an example ship. And the bulbous bows are now a bit difficult, too much maybe to explain. And yeah, you have to make a decision about, do you want a V-shape off ship or U-shape off ship or a round off ship? But it's really up to the designer. But what we normally say is you need, at least from the midship, you need one aft curve and maybe one in between. And here in the front ship, well, you see the midship, and you see that we use a bit more, 2 or sometimes 3 in between curves, but not more than that. There's a limit. It depends a bit on the ship type, and that's something we learn more. You go more deeply in the training. Gerard, I had another one question, which is interesting. It was, can you explain the record history? I will show it again. Maybe that's better. And then try to explain how it works. Certain commands in Rhino can be recorded, and it means that the child, which is made from certain parents, it will change when you change the parent. Now, in this case, we have loft curves, and with the command loft, well, first have to put in the bottom then record history. And now it's recording the command that I want to, that it keeps its history. So it's now recording that I'm typing in loft. It's recording that I'm using these curves. And it's recording the options that I choose. And I choose loose and do not simplify, and I press OK. So this is all recorded. Now in the bottom you see that record history is off again. For the next command I can use it again. But if I now change one of the loft curves, the hull shape is changed as well. So that is the whole idea about record history. Okay, Gerard, do you have another question maybe to answer?
Yeah, there are many nice questions actually. Totally different than the morning session. So I will try to answer them. One.
Can I make you presenter?
Yes, please. So one remark from someone is that, hey, this is more of a sales pitch than a training. And I totally agree with you. We thought about, well, what do we want to offer? On the Rhino Center blog called Rhino Report, you already can download a lot of resources for free for years now. So we share a lot of stuff for free, but also we have to maintain our business, and we have to ask you to pay for the knowledge we developed in years, actually. So what we offer you is years of falling into pitfalls in modeling, fairing, etc. In a webinar of 1 hour, we cannot teach you the stuff that we teach in a 4-day classroom training. So we can only touch a few subjects, and we can show some specific things in this webinar. But no, this is not a training. And that was also what I wrote down at a later time in the webinar description. It's a demonstration of what you can do with Rhino, whether you do the training or not. So maybe you think, hey, I can teach myself. Well, you're welcome to do that. But maybe you also understand that when you pay for the training, you don't need to exercise and fall in all the pitfalls that we fell in the past. So, of course, yes, this is a sales pitch, but it also hopefully gives you confidence in what you can do with Rhino, but maybe a lot of people are not aware of. And a lot of people think, hey, I can only use this, do this with MaxSurf or other software. And there's nothing wrong with MaxSurf, but there's another price tag to MaxSurf, and some things you can do in MaxSurf that you cannot do in Rhino, even not in Orca 3D. But it's up to you to make your decision. This is what we can present, and so that's what I wanted to clarify a little more. Now back to the naval architecture and the modeling and the fairing. One question from Craig Bjarnason, actually. What's a reasonable Gaussian and curvature range for the curvature analysis for steel or aluminum plate hulls? I found out that the Gaussian analysis that you saw in the workboat example, so if I say curvature analysis, the setting over here depends on the size of the ship. And what I found out is that I just play with this setting, and in the end, most important is when I unroll this surface, Rhino gives me feedback over here about the accuracy. And this is for me most important. So the setting is important, but it's not an absolute setting. It's a relative. Depends on the size of the ship. Another question from Peter Forsane is, do you have a simple way of making a hull of, let me see, here. Well, where is the question? Yeah, do you have a simple way of making a hull of a laser scanning? Well, actually, that's the same that I have done over here. But then, what you need to do is to create these curves based on the laser scan. So then you create in a laser scan curves that are exactly on top of your points, and then you create the reference ribs on top of that. So no, you cannot convert, for example, a mesh into a NURB surface with clever tricks and tools. What we found out is that you always start from scratch with a new surface, and then you try to make it as accurate as possible. In my contacts with the Dutch Maritime Research Institute, MARIN, I gave some training over there in the past. They showed me their system when they receive files from clients for their towing tests and their CFD analysis. They too always, or I think mostly, create a new hull shape from scratch, and then they pull and drag the surface within a certain accuracy to the original input from their client. So yes, it's labor intensive, and it takes you a lot of time to become a master in this. But with the training techniques that we teach you, you have at least the tools that you need. Let me see another question. I saw an old friend of us in the list, but maybe at a later time. Let me see. There's so many questions. It's so different.
Maybe this is with the screen you have open, Gerard. It's maybe nice to answer this question. Amitava asks, I'm interested to learn how to develop ship hull from a large number of points. Typically, these points are extracted from structural analysis models, such as an STL file. So yeah, somebody who has a lot of points.
Yeah, again, when you have an STL file, which we call a mesh surface, then you need to create sections in that mesh surface and use the section curves to create reference ribs. So with reverse engineering, in our practice, you always use your input to create curves that you use to create reference ribs, the orange and the green ones, and then you start all over again with a new surface which you fit to that original input.
I have another nice question which I can answer. Shall I take it over?
One command, because Peter Rosenthal, he says, how is raising your training prices 20% from $9.99 to $12.75 and then offer a 20% discount? I have been thinking a lot about the pricing structure for this online training, but maybe to all of you it's interesting to understand that when I offered this classroom training since 2012, the price per trainee was 1,980 euros. So per person, you had to pay 1,980 euros to attend the classroom training. So I think that the price of 1,250 euros is already very affordable compared to the 1,980 euros for this professional training. So it's a training focusing on a professional job in a professional company. So it's not hobbies projects. And a lot of people use this for hobbies, and I'm fine with that. But especially for this webinar, I thought, let's give a big discount for all of you that put time in this webinar. So 1 hour of your time, you are interested to see this webinar. And we can make a long discussion about pricing structure, but it's up to you in the end, whether you think it's worth it to pay the price that's on the tag. So I leave it up to you, and I'm fine with anyone who think it's too expensive. But I wanted to explain to you a little more about the pricing.
Hey, Gerard. This is Mary
yes.
in Seattle. We had a question about whether the training expired, or how long do you get to use the training modules?
The training is what's it called? Accessible for 3 months after purchase. And that is important because I don't want that especially larger shipyards or design offices pay for one training and they hand it over from one person to another one. And in, well, the end, in 1 year of time, 4 people can do the training for the price of one. Because when another client who purchase and who has a single man company, it would not be nice for those people who have to pay that price and a big company only purchases one. So we cannot prevent that totally. But that made me decide to limit the online training to 3 months. But of course, if there's force majeure and you are in a hospital and you have other problems, we can always extend this 3 months. But to keep it simple, it is a 3-month time.
Okay, that's perfect. So 90 days, and I also think with a 90-day training, you're more focused on actually doing it. So if you buy training and you have it forever, then you always procrastinate as everything comes up. So I think with human nature, that 90-day limit is really good for planning. Another question about the training: is there a prerequisite, or if you're just interested in doing marine models, can you start the training?
Yes, very good question. In the training description of the Hull Design and Fairing Level 1, there is written that you at least have to do the Rhino Level 1 training that you can download for free on the McNeil website. For anyone who is interested, we offer this training also, and we call it online Level 1 training, and then you pay a little price for 4 extra support hours. So you can do the training for free on your own, or you purchase via Rhino Center, and then you receive 4 support hours. Because what I found out in offering the Level 1 training to hundreds of people in 10 years is that the level 1 training is very valuable, but doesn't teach a lot about how Rhino works. And that is what we teach in the online support. And that goes via Skype, actually. Yeah.
Okay, great.
Another.
I think that's it from here.
All right. Thank you, Mary. Bas, do you have something? Oh, there was this question about whether this webinar is only Rhino or is a combination of Rhino and Orca. This webinar and the online training is only Rhino based. So you only need Rhino to do these type of jobs and to do the training. However, having said that, I think that Orca 3D is a very valuable add-on for the naval architects. Yeah.
I have a question here. Somebody asks, does the training offer a cover background of explanation of grasshopper parametric modeling? You want to answer that?
Yes, I see it now. No, this training is not focusing on Grasshopper at all, because that's a whole different topic. And what I found out, that anyone who is interested in visual scripting with Grasshopper, it is very important to learn modeling by hand first. So then you know what Rhino is capable of and what not. And then if you model something 5 times in Rhino, well, then that's a good point to say, now I convert my labor, my hand labor, into a Grasshopper script. And yeah, that takes time to get used to the Grasshopper approach, but as I am a designer with a visual approach, coding scripts by typing code for me is too abstract. And Grasshopper enables me to script Rhino in such a way that I can make parametric geometry. So for me, it's a good thing. And this morning there was this question whether there will be Grasshopper training at Rhino Center in the future. I hope that we can develop training material regarding Grasshopper scripting for the maritime industry in the future. Right now, you can already find a Grasshopper hull script on the blog Rhino report, and you can download that for free. And that reminds me of another question that was asked earlier in this webinar. If this Grasshopper scripts that we provide on our blog is already updated for Rhino 6, and as far as I know, it works fine. So when you download Grasshopper scripts from our blog, you should be able to run it in Rhino 6.
I have another nice technical question, and that's from Claudia. To make a loft surface with the command loft, does it have to have a correct sequence? And we can show you a bit the tricks.
Okay, so we move to you, Bas, now.
I will, yeah. You can look to the other questions.
Yeah.
We'll do undo and do the loft again. Well, Claudia, it is partly correct. Yes, they have to be in the right sequence or not. At least it depends on how you use the loft command. I will use it now without record history. Loft, type it in. And if I now click on the curves, and for example, you saw that I'm clicking on the upper side of the curves, and I will click one at the bottom side, and the other one's up again. And if I now press enter, you see it is twisted. And that's because Rhino knows and is smart that it is recognized where I click at the end of at the start. So, and this is something as shipbuilders we don't want, but maybe other designers want this. So that's why it's in this loft method. It is listening to to where you click. Another example if I use the right mouse and my right mouse button to repeat the command loft. If I now click and I click this one and I miss that one and then think, hey, I want to do that one, then it goes that way and then back again. So that's something you don't want, and it's difficult to see because it is so flat. You can't see the difference that it is double. But be careful with that. You shouldn't do, and that's especially when you use record history and you use and if you select everything together. Rhino has an algorithm behind it that it automatically loft nicely and not without twisting. If I say okay, but something you should avoid with loose loft is, for example, now that you use record history and then move one of the curves out of another one, and then you see it going to be very ugly, and you get a very bad shape as well, and a bad mathematical product within Rhino of the nerve surface. So don't do this, and it's the same with control points. When I teach students, a lot of students, they drag a lot with the control points, and at a certain point they don't know the order anymore, and that is something you should take care of. So this is very wrong what I did now, because now this control point was above the other one, and if it's now twisted, it's hardly you can see it. And there are commands in Rhino to check the order of the control points, but try to avoid it. That's something you should look at. Okay, Gerard, maybe you have another question.
Well, I saw a question about that the hull surface doesn't touch your loft curve everywhere.
Ah, yeah, that's something, that's correct. Well, it's very here, we can see good example. So the loft curves are not ordinates, or they're not frames. The loft, in principle, is like when I make a curve. Here we have a curve, and the control point here. Oh, I will first finish the curve, put the control points on. This control point is not on the curve as well. And it's exactly the same with the curves of the surface. They're not on. Only when it's the end of the surface, like here, this control point here, and that control point there is on the line, the end curves are on the surface. And when we have free curves in a line, then they get, at least the last one is on the surface as well. So that's why the midship is really on the surface as well. But all the others are like pulling forces to the surface, and that makes it so nice to use as to make fair ships. Okay, hopefully this explains your question. Gerard.
Yeah, I can tell a little more about this. What I found out is that when I learned myself this technique, I also wanted my surface to run through specific points. And it took me quite some time to accept the fact that control points of a surface are not always on the surface. And in this approach, the loft curves are also not always touching the surface. But what I see is that also in other hull fairing software, when you turn on control points of the surface, they will also not touch your surface. The reason that we teach this rapid hull modeling methodology based on loft curves is that you have sort of a simple DNA because you have a set of curves, and then you create a surface out of them. So this is not better than doing direct control point modeling on the surface control points. It's just a little different approach that has pros and cons. So it takes some time.
I saw that some of the people that they had used MaxSurf, and MaxSurf is using the control points of your surface. You can do in Rhino as well. The disadvantage of this is that you have always need a lot of control points. So if you need one curve with a lot of control points, all the other places has a lot of control points as well. While with the loft method, this curve can have a lot of control points because we need a lot of shape manipulation. But another curve can have less control points. I don't know if it's in this case. Yeah, here I think I put in on this. I can better put it on maybe on X-ray. You see, this one has 3 control points, while this at the bow has a lot of control points, and that is really an advantage of the loose loft method.
Mm-hmm.
Okay, Gerard.
Yeah. There is actually a question from a MaxSurf user, and he exporting services to another software is also taught in your training, because he experiences that not always an export from Rhino to MaxSurf is successful.
Oh, I'm surprised. Okay.
Mm-hmm. So actually, no, we don't teach it because I don't know about MaxSurf. I don't use it. And for example, export to AutoCAD, when you have a new AutoCAD or a new MaxSurf, some things work, some things don't. So we don't teach it, and we leave it up to the people who use the method or use Rhino to find out themselves. But we are always willing to discuss with software developers. And for example, I have done a fairing job for a Dutch design office recently, and they use Cadmatic for structure modeling. And then we were also discussing with Cadmatic about several improvements to combine Rhino hull surfaces with Cadmatic.
But Gerard, for the MaxSurf example, I've tested it quite a bit at the university in Delft. And the loose loft method surfaces in Rhino and the surfaces made in MaxSurf are, to my opinion, quite compatible. And you can share them. Maybe the other types of surfaces are getting a problem in MaxSurf, but the loose loft surfaces are, to my opinion, can be easily transferred.
Yeah, well, and we always are willing to take a look and support people who work with Rhino when we can answer a question and it doesn't take too much time. We don't charge money for it. And if we find out that we really have to study for a solution and get in touch with companies, maybe discuss with McNeil that, well, we have a problem or our client has a problem. So then we can always do consultancy for people. And that's always within reason. So if it's a quick question to answer, we do it for free. And if more time is involved, then we need to charge some money. Another question that I think is very a good one. Is the training suitable for self-taught student, one who has not studied naval architecture? Yes. You don't need to be a naval architect to model a shape. The only thing that you need naval architecture competence for is about, for example, what should be the displacement, or where do I need to have the center of buoyancy compared to the center of gravity. But I think that many people first start with modeling just a nice hull, and then you can always consult a naval architect to do some analysis about the volumetric displacement, the center of buoyancy. But that so you can always use, well, these techniques and use the training to learn to model a nice hull. and do the naval architecture afterwards with a specialist. Of course, it is always better to know about what the goal of your specific hull is, so that you have an idea about, well, this yacht should be 5,000 cubic meters displacement, and then you can go for that goal. But this training doesn't focus on naval architecture, it focuses on modeling, fairing, and reverse engineering. Let's see, another question. Okay, the problem are trimmed surfaces exported to MaxSurf. So maybe it's better to get back to this at a later time, or to be in contact with Paulo Duarte. We will receive a list of all the questions after this webinar, so we can see what we can do for you. Let's see. For me, it's
Gerard, did you answer the one that says, should you use the model to calculate stability of an existing ship?
I'm
I'm not sure if Peter means if the ship were laser scanned.
Okay.
You can.
I can't find the question, so maybe you can copy and paste it into our chat box.
Sure. Okay.
So Mary, can you repeat it again? The question
Sure,
is?
Boss. The question is, it's a little vague, but we can probably come up with a few answers. Should you, if you have an existing model, can you use Rhino to calculate the stability? And would you loft curves for that? So I'm not sure if the existing ship hull is coming in as a scan or...
Okay, that question is clear. This question is clear. The term stability is a bit wide. What the basics, of course, yes. What we do if we get a client who has a scan or an old drawing or another way, a model, then we can reproduce that by using the loose loft method with the ribbon method that Gerard showed in the previous presentation. And then in Rhino we can use hydrostatic data, get data of it, but that's not yet stability. And stability is not in Rhino. You only can get the volume and where the center of volume is, etc. And there are other add-ins like Orca, where you can calculate the stability with. But that is not in Rhino. Although Naval Architect can calculate the, based on the information in Rhino, he can calculate the BM. But for example, you can't put weights in Rhino, so you have to do it in a separate program or in a spreadsheet. So I hope this answers your question.
Yes, thank you. We can see if there's any more questions. There was one more. Do you demonstrate modeling decks with camber from shear in the training?
Yeah, I saw that question also. No, unfortunately not. What I found out is that this training, which we offered many times as a 4-day full-time training, didn't allow me to integrate also the modeling of decks and other hull details. So I am currently working on another training module that will take that into account. So making portholes and also decks, but that's another topic. So unfortunately, no, it's not in this training module.
Great.
But it's possible in Rhino. Yeah, it's possible to do it in Rhino. That's already.
Of course, yeah. It is. With Rhino, you can model anything, but it's not taught. Yeah.
Okay, well, we'll look forward. You'll let us know when that's ready.
Yeah, it will take
Okay.
a lot of time. I mentioned this morning that developing this training in total took us 9 months full time. Think about what do we want to teach, how we built up the curriculum, develop exercises, writing them out, and then when I decided to convert this into an online training, Tobias, Bas, and I, it took us weeks to create all the exercise videos. So yes, it takes a lot of work to create only one module. So that's maybe a little background.
Gerard, can we assume that whether you have Rhino 5 or Rhino 6, you can do the training?
Yeah, you don't need Rhino 6 for this training, and you can even do it with Rhino 4.
Perfect. Okay, thanks.
I have another technical question. Maybe it's nice for close this. The question is, what if is it also possible to expand the curves to the outside of the bounding box of the half ship? And yes, it is. It is possible. For example, if you take one of the curves and then bring it outside, I can later cut off this. And it's something we often use for more complex ships, that we loft it to the other side and then cut it off to get more difficult shapes. What you should avoid is go beyond the breath. That always gets nasty. But it is always good to loft above the depth. So go higher. It's not a problem at all, and you can cut it off later by trimming.
Yeah, that's one thing. Very good that you show this, Bas, because that's what I see a lot with people who model ship hulls, is that they don't extend a hull up enough, and then they create a second one in the bow area to extend the hull, and then to extend it a little more even in the superstructure. So you can often better extrapolate a hull too high and then cut off later the protruding part. There is also a question, if I understood correctly, you are able to integrate a hard knuckle into a curve. Is it possible to fare a hard knuckle out as the hull continues aft, for instance? So fading out a hard crease. Maybe you can show this knuckle bow example. Yes, it is perfectly possible to fade out a hard crease, but it takes often more control points to define the specific length of the fade out and the position of it. So the example that Bas will show you now is the most simple representation of a knuckle in the bow area. But if you, for example, show glossy for fairing, Bas, and turn off the loft curves, then people
maybe it's nice to show here the zebra. What do you think?
No, first please the glossy for fairing to show where the knuckle vanishes away. So now people can see, if you zoom in and maybe make perspective full, yes, please. And now in where you see that the hard knuckle fades out into the midship. So, but the position where that is, if you zoom in, please, yes. So now people can see where the knuckle fades out, and actually the position of the fading out you determine with loft curve positions or control point positions. So it is doable, but it takes also your skills, how much control you have. So I hope that answers the question. Then there's this question, can those scripts from your blog, and I think Evelyn Paychef, he refers to the Grasshopper scripts probably. Can those scripts from your blog be used commercially, meaning directly, or modified to be used for models user can sell, not selling the script? We provide these scripts for free for anyone with good intentions. So if you think, or if you are actually making money with the scripts, it would be fair that you determine what would be a good price to pay us, because we share them for free and we leave it up to you if you value the scripts and pay us something for it. So that's one thing we do for the whole industry. So we don't sell everything, but we yeah, it's up to you. Let me see. I think it's 6:30, and maybe it's a good time to finish this webinar. And before anyone has left, I would like to thank anyone for taking the time to attend this webinar. And I really do hope it was valuable time for you. For me, it was big fun. It's exciting. Also to have these critical questions. Yes, I think they are part of a webinar like this. I would like to thank Bas for his support, and also McNeil, Mary Futier, and Rodrigo Barcena. And as I mentioned earlier, we will answer a lot of questions on the Rhino Center page that presents this webinar, and maybe we can answer some questions via email. At last, you will receive next week a link to the recording of this webinar or this morning's webinar. It depends a bit on the quality of, probably we choose the best one. And yeah, I hope to see you again in the future, and feel free to contact us with questions or remarks or feedback on this webinar is also appreciated. So yeah, I would say thank you and goodbye.
Goodbye.